it again? What was your question? Not at the moment, not focusing on that. Your next homework is what I'm focusing on right now. Getting that to you by Wednesday. So we're going to go through streams today, and then we're going to go into some more involved examples. So a stream is a generalization of just some source of input of characters. So some way that you might have streams are like files, the keyboard, output to the terminal, and then strings themselves could be written to using string stream. You've already worked with some of them, like cout and cin. But if you want to work with file streams, they're included inside Fstream. And there's three types of streams. There's an IF stream, an OF stream, and an F stream. IF is for reading, OF is for writing, and F stream is for reading and writing. If you want to open a file using a file stream, when you call the constructor, you can specify the name. Or if you don't specify the name when you call the constructor, you can call .open on the stream, and then it will open up that file. If you want to check if you already have a stream open, you can call isOpen. And if you want to close the stream, you can call .close. But if you don't call .close and your stream gets destroyed, its destructor will automatically close it for you. So you'll never end up with open files sitting around anymore. So this is the way of opening it with the constructor, or we can create an empty one and then call open on it. If you try to open a file that's already, if you try to open a file when you already have one open, it's not going to work and it will fail opening that other file. If you want to check if the file is good to read from or write to, just wrap that file or wrap that stream inside of the if statement. If it evaluates to true, you're good. If it's not good, you can't read to it or write to it, from it or write to it. You can just say if the file is good, use it. Otherwise, you can't use it. If you want to read from a file stream, you use the arrow just like in. cin is also a stream. If you want to read a line, you can say get line, stream, and then string. You can also provide an optional delimiter. By default, the delimiter defaults to the new line, so it reads until the new line character is found. Or you can give it some other character and it'll keep reading characters until it finds the delimiter. It won't actually read the delimiter out, it'll leave it there. So you may have to get rid of it later on using a call to like get. If you want to ignore characters, stream.ignore end characters or up until a delimiter is reached. If you don't want to have a limit and you just want to keep going and skipping characters until you reach some delimiter, you can use numeric limits, stream size, : max. That's basically infinity. Keep going until you reach the end or until you hit that delimiter. So you can open up the file, try reading some stuff into it. It will do the formatted input for you. So it's actually going to read in the characters of the appropriate type and then transform that into the number. So num will actually have the integer value. D, don't know why that says file, and should be file into D. And then D will actually be a double, have the value as a double. You get some string. Don't know why that's there. That's all backwards. File goes into S. That would get you the first string, which would be a sequence of non-white space characters in the file. Or you could say get line S, or you could say get line from the file into S. That's where the results will be stored until you find a comma. Or you can ignore the first 55 characters up until you encounter the first colon. Any questions here? You can also get a single character using get. If you're not able to get something, it's going to return EOF. So you can check to see if the character coming back is equal to EOF. That means there's something left and you can stop reading. You can also peek to see if there's anything left. So you'll look and see what the next character is, but not actually extract it. So you can say like, hey, C equals file.get. If the file.peek, if the next character is A, do something. Right, but you're still going to leave the A inside the stream. If you're writing, you can just use the arrows to write into it. One of the things with streams is they can't be copied. So if you want to pass an open stream to a function, you're going to need to pass a reference to it. Shouldn't be too complicated. So if you got rid of this ampersand, you would get an error as you were trying to copy in the file stream. And then it'd be like, nope, you can't do that. I can only be moved. But when you're doing the reference right, you're not getting a copy. You're just getting basically a pointer, that thing. There's also string streams, which can be useful for changing the types of things. Or if you have multiple things that you need to read in and then convert them. It's pretty similar to scanf, but a little bit more flexible. So if we had some string stream SS that started as 5, 25, and 30, we could read in the values from it to get 5 into num1, 25 into num2, and 30 to num3. That's streams. Shouldn't seem too complicated. Do you guys have any questions about them? Yeah. No, it's doing the formatted read. So it'll read the first integer out, which is 5, and convert that string representation into the numeric 5 representation. Or when we get the 25 out the second time, it turns the character 25 into the number 25. So whenever you read something in using the instream operator, it will format the input first to be of the correct type. If the format fails, it will not be initialized to anything. I believe it leaves it there if it fails. So as an example, let's say that we wanted to be able to write a program that's able to read a CSV file. So CSV stands for comma separated values, which means the values in our files are separated by commas, right? So it's pretty well named. So we might want to be able to write like a wrapper class for CSVs to make it easier to read from them. So I've defined this class called a CSV reader, and we can be initialized one of two ways. Either you give me the file name and what the delimiters in the file are supposed to be to separate things out, or if you just give me the file name, I will use the default set of delimiters, commas and new lines. We might want to be able to read the next field, but we might also want to be able to get the next field out of the file as either an integer or as a double. We might also want the ability to just read the entirety of the line as a string, or potentially read the entirety of the line as a vector of strings. So split it into the individual components. I also have rewind for bringing me back to the beginning of the file, and a function to check to see if I'm at the end. We'll talk about iterators in a minute, but we'll ignore them for right now. And the things that I have for private is I have a function that tells me if a character is going to be a field terminator, does it mark the end of the field. I have an in-file stream because all I'm planning on doing is reading. And I have my string, which is my set of delimiters. Any questions here? So here's my function, here's my constructors. I say, hey, open that file, it has that name. My delimiters are going to be initialized to whatever delimiters you give me. The other one calls the first constructor, again, with whatever the file name is, but we make our set of delimiters equal to a comma and a new line. Any questions before I move on? Yeah. So there are two separate ones. A comma it marks the end of a field, and a new line also does as well, right? Because we can see that the fields are separated by commas in between, but each row is separated by the new line character. Any other questions? Okay, so I want a function, and it's supposed to read the next field. So what I do is I have this field to be able to store my characters, and I really wanted to use getLine and provide a delimiting string to help me just read until I got that field, but you can only accept one delimiter, either a comma or a new line. So if I tried to use getLine and pass it as a delimiter or a comma, when it got to the end of the line, to actually read the next two fields. So I have to do things here manually. So I get the next character out. If it's not equal to the end of the file, then I'm going to check to see if that marks the end of the field. If it does, leave. Otherwise, add that character to my field. And then at the end of the day, I return the field. And then I advance to the next character in the file. Questions here? Okay. So reading a line, I just call getLine. Reading a row, I have a vector of strings to represent my row. And then I have my current field that I'm trying to build up. So again, that for loop looks pretty much the same as it was last time. But if I reach the end of a new line, if I reach a new line, I finish that row. Otherwise, if this is a field terminator, something that's supposed to be in between, means I've completed my field, so go shove it on to the end. Which makes me think that this is now wrong. Because I don't think I'll have the last row. Right? Because I'll be like, oh, I got a new line, and then I won't have added that field to the end. Right? If I've reached the end, if I reach the new line, I must have reached the end of the field, so I should add it on. Then otherwise, if you reach something in the middle, we add their field in, and then we clear the field. This gets rid of all the characters that were there. And then otherwise, I just add that character to the field because I'm in the middle of the field. Again, I really wanted to use this guy back here, like this read next field, but the problem was I didn't know when I reached the end of the line. So if I want to figure out if something is a field terminator, I use this function in the algorithm library. Algorithm has a lot of really useful things. So with find, you pass it a iterator to the beginning and to the end, or in more general, over the range of the container that you want to search through. I want to search through the entire thing, and I'm looking for the value C, whatever that character is. If the value that I get back here, which will be an iterator, if it's equal to the end, it means I don't have it, because I searched all the way through the end, and I didn't find the thing. Otherwise, it's going to give me an iterator to the first position of that element, right? So if the position that it's giving to me inside the vector or inside the string is not equal to the end, it means I must have found something, so I can return true. But if it was equal to the delimiter, or if it was equal to the end, I didn't find it. Any questions here? I do recommend looking at algorithm. It has a lot of useful things inside of it. So I also wanted to be able to get the next field as integers. So there are some conversion functions. This is the string to integer function, stoi. So get the field out as a string, and then stoi to convert it to an integer. String to double will convert this string into a double. Rewind is, you can use file.seekg. Seekg is a lot like seek. It tells you where into the file to move, and I want to move back to the beginning of the file. Checking if I'm at the end of the file, I peek, and I try to see if I'm at EOF. And then again, ignore the iterator stuff. Any questions here? Does it all make sense? So the other thing that I made was, sometimes you might want to work with your CSV like a 2D array. So I made this other class called CSV. So you can see here I do some type defs so that I don't have to keep typing out so much every single time. So row type is another name for a vector to a string. Iterator is another type for this row type iterator. And there's also for a const iterator over here. Again, we'll talk about iterators in a minute, or maybe tomorrow. But what we do for a constructor, one thing to note is that when you declare the usings inside the class, they're inside the class's namespace. So if I'm outside the class and I want to access row type, I have to say CSV : row type. Or if I want to access the iterator type over a CSV, it's CSV : iterator. So here I can construct a CSV from a file name, and then also whether it has headers in the file or not. I have an @ which is going to give me that row, give me this the ith row, and then I have a const and non-const version. Again, we'll talk about iterators in a little bit, and then I also have a function to get me the headers. And then this is the next topic we're going to talk about, which is operator overloading. Over here, I've defined how the outstream operator should behave. So if you get an outstream reference and a CSV, I know how to write to that outstream. So to construct my file, I create a reader file name. If we're supposed to include headers, I read that row. Otherwise, until we've reached the end of the file, keep reading a row and keep adding it onto my list of rows, right? That vector of rows. .at is not very complicated. Just give me my data at whatever row you wanted to read from. And then getting the headers just returns the headers. So this is my outstream operator, which tells me how I should write to it. So if for each of my headers in my headers, right, write them out. If I do have headers, right, I'm not empty, put a new line there. Then go through each row in the CSV, go through each field in the row, and then output the field followed by a space. And then output a new line once you've reached the end of the row. And then I'm done. So over here in main, I create a CSV, and then I just print it out. So now, since I defined since I defined the outstream operator for a CSV, I can just put it in there and it will be written out. And you can see that we now print out the contents of this CSV file over here. Name, breed, age, sex, buddy, yellow lab 3 male, lady boxer 5 F. Everything prints correctly. You guys have any questions over here about the CSV reader or the CSV file? Yeah. Yeah, we're going to go over that in a bit more detail in a second. Do you guys have any more questions? Okay, so let's talk about operator overloading. So operator overloading is defining how the built-in operators, plus, minus, times, etc., operate on instances of your class. So you define functions that should be called whenever we encounter this operation with your class and some other type if it takes another type. These are a list of all of the operators that you can support if you wanted to. It's a lot. There's 38 of them. And there's also casting operators that let you specify how your object should be cast into another type of object. One reason why we might want to do it is it might make your code a little bit more readable over having to do function calls and a little bit nicer to write. This is really useful for like mathematical types, such as like matrices or complex numbers or polynomials, right? I want to be able to do matrix plus matrix, matrix times matrix, instead of having to do, m dot add some other matrix. It just reads a lot more naturally when you're able to do that. So there are two different syntaxes that you can use to overload operators. The first one is return type, the keyword operator, followed by whatever the actual operator is supposed to be, plus, minus, times equals, divide equals, whatever it wants to be. And then any argument it's supposed to accept, which would be the right-hand side. So if we're doing something like a complex number operator plus equals, a const complex number right-hand side. So when you do it on the inside of the class, you are implicitly the left-hand side of the operator, right? So if you do like a plus b, a minus b, a times b, you're always the a part. The b part is the guy on the right-hand side. That's the argument that you accept. Some of the operators are unary, like for example, like the negative sign, right? That operator wouldn't have any arguments, right? You want to negate yourself, or you might want to dereference yourself. The question? So you're talking about here, this operator? Say that again. In 1A. So operator here is the keyword operator. So you can see that operator appears over here. So it is a keyword. And then the actual operator is the plus equals, minus equals, times equals, divide equals, whatever you're trying to do. Yeah. So you want to do like an overloaded operator that modifies yourself, like the plus equals, for example, right? Well, generally, if you're doing like the plus equals, minus equals, times equals, you return a reference to yourself. So you can see here that my operator plus equals returns a reference to a complex number. So probably what I would do is I would do the addition and then return star this, return myself. If you have functions that like a plus b, a minus b, generally the return type is either a const or non-const version of your class. So if I wanted to do just a plus, I would just say complex num operator plus. I'd be returning a copy, right? I'm not going to modify myself, and I'm not going to modify the thing that I'm passed in, which is why it makes sense to have const here. If you want to do it outside the class, it's return type operator, whatever the actual operators are, then arguments. This one is not a member of the class, so it's going to be taking two arguments. The first argument will be the left-hand side. The second of the operator, the second argument will be the right-hand side of the operator. Or if you're just a unary operator, you would just accept yourself. A lot of times you have to use the second method if you don't want yourself to be the left-hand side, right? Here, if I'm using this first version, I can do complex numbers plus, minus, times, equals, whatever I want on the right-hand side, right? So I might want to do like, I could do like a complex number plus an integer, or complex number plus a double. But if I want to do a double plus a complex number, I can't write it that way, right? Because you are always implicitly the left-hand side when you're a member method. But on the outside, we can say, hey, who's going to be doing what, right? Who's going to be on the left-hand side, who's going to be on the right-hand side. So then I could define, complex number plus, complex number operator plus, and my left-hand side could be an integer, and my right-hand side could be a complex number. So that's how I could make myself symmetric with the other types that I want to support. Friendship is something that we still need to talk about later on, but the brief way of it is, right? Normally, when you're outside the class, you can only access the public member methods and the public members of that class. If you declare somebody as being your friend, they have access to your private parts, right? So your friend has access to your private parts, so they're able to access every single one of your members, regardless of the protection level that you've declared. So if I say that this operator plus equals is my friend, it can access the private portions of complex num. So if you want to call an overloaded operator, it's not too hard. The implicit way is you just do it like normal. Plus equals, minus, times, equals, whatever you want to do. Or you can explicitly call it by its name by doing like your member dot operator, whatever the name of the operator is, and then the other side. If it's defined outside the class, operator plus equals F1, F2. Any questions? Yeah. So when you overload an operator, there can only be like one operator that defines that particular, like, if it's like the operator plus those two particular types, right? So there can only be like one operator for a complex number plus another complex number, right? If you try to redefine it, you'd get an error saying that that function was already defined. But there might be, another like operator plus for like a fraction and a fraction. That's fine because the types are different. So if you want to specify the unary versus the binary versions of some of the operators, right? Like star has a unary and a binary version. There's star var, or var times some other var, or minus var, negative var, or some variable minus some other variable. The way that you do this is by specifying how many arguments the function takes. If it accepts 0, it's going to be the unary form. If it accepts 2, it's going to be the binary form. Or if it accepts 1, it's going to be the binary form if defined inside. If it's outside the class, 1 is unary, 2 is binary. One other thing that you might want to do is specify a pre-increment or a post-increment. The way that you do that is by passing in this extra dummy argument to the operator. So the ones that don't have the dummy argument are going to be pre-increments, and the ones that accept that argument are going to be post-increments. And these post-increments should be returning copies, not references to the original. Otherwise, you're going to get just the pre-increment behavior. Again, you can overload your operators to accept any other type as an argument. They don't just have to be yourself. So we can have our complex number accept an integer as the right-hand side, or a float as the right-hand side. And then outside, again, we could do complex number left-hand side as an int, complex number right-hand side. But again, like we said, if you want the other type to be on the left-hand side, you can't do it inside the class. It has to be defined outside the class. So operator plus int is now the left-hand side. Complex number is now the right-hand side. So now I can do 5 plus some complex number. But before I couldn't. One thing that you can do is you can reduce a lot of your code writing by defining only some of the operators and then just recalling them. So if you define like the op equals version, like plus equals, minus equals, times equals, in the plus version or the minus version or the times version, you can just create a copy of yourself, assuming you're copyable, right? And then do that copy plus equals the other thing, then return the copy. This saves a lot of rewriting of the code. So if we had a plus equals operator for imaginary numbers, right? I can do my real plus equals the right-hand side dot real, my imaginary plus equals the right-hand side dot imaginary, and then I return myself. To get the operator plus, I make a copy of myself, then call this function up here, plus equals onto the copy, and then I return the copy. Does that make sense? Or for example, if you wrote operator equals equals, you get operator not equals for free, right? Just return not equals equals. Yeah. The question is, can you define the plus and get the plus equals behavior? It's not as easy, and probably it's more expensive because you'd have to like copy yourself over into if you had the plus operator, you have to like copy yourself over. So not as easy to do it that way, but you could get it to work, I think. Any other questions? You can also overload, like you saw, the instream and the outstream classes. If you want to overload the instream or the outstream classes, the first parameter, what you should return is an outstream reference or an instream reference. The first parameter will be a reference to the outstream or the reference to the instream that you're trying to read from or write to. And then the second parameter will be a const reference to whatever the class is. Because hopefully in reading the class, you're not modifying it. So it should be const. So as an example, we might have a friend. Again, this friend now has access to our private part, so they can access our private member variables. So I wouldn't have to provide getters and setters here. And I return an outstream reference operator left shift. I get that outstream reference over here, and then I get a const reference to an instance of my class. And then I also have over here, once again, the instream, which looks more or less the same, except our types are now istream as opposed to outstream. If I wanted to write myself out to the stream, I would do out, and I'd put my real part plus my imaginary part, followed by an I, and then I can return out. because out has now been modified by writing into that stream. If I was trying to read in, and I assumed that my input that was going to be there was, some number plus some other number I have a couple of dummy things to capture those additional characters. So I read the values in, and I discard the dummies into these variables here, so that I'm actually able to read the values. And then again, I return in. Any questions on the outstream or instream operators? Some common practices, the right-hand side arguments are always const references. This is again because like when you're doing a plus b, a minus b, a times b, do you expect b to change? No. The operator equals will always return a reference to themselves. For the non-equals operators, you'd return a copy of the object. Also, that function should be marked const on the outside of the function because you shouldn't be changing yourself, right? When you do a plus b, should a change? I wouldn't think so, right? So if you're doing it as a member method, you would put a const there at the end to signify that you don't change. If you're doing the outside method, both the left-hand side and the right-hand side will be const references because again, neither the left-hand side nor the right-hand side should change. These rules are there so that your overloaded operators behave like standard versions, like the way users expect them to behave. That being said, you're free to do whatever you want, and people can get really confused and messed up by your overloaded operators because they have expectations on how plus should behave or minus should behave, right? If you want a version of plus where you do a plus b and all of a sudden a changes, you can write that function. But somebody's probably going to be really confused when they do a plus b and they get a different value for a. The other thing is that you can also create casting operators, which just specifies how your type should be cast into the other type. The way that you do this is operator, name of the thing that you would like to cast to, parentheses, and then const, because you shouldn't be changing and creating this new object. Yeah. Yeah, it works for non-primitive types, right? String is not a primitive type. Which probably should be std : string, but you can absolutely cast to another user-defined type if you want to. So I have type A and type B. So type A, B, and type BA. Okay, so, and then AB wants to be convertible to a BA, and BA wants to be convertible to an AB. Let's just do A and B, right? It's just easier to think about, right? So A wants to be castable to a B, and B wants to be castable to an A. Okay. So these can be useful sometimes. For example, the outstream operator the instream operator and the outstream operator, they both define an operator bool to convert themselves to a bool. And right, that value of that bool when they get cast there, so we can use it in the if statement, will be true if it's still good to read from or write to that stream, false if it's not good to still read from or write to that stream. So it defines that method there. And we'll do some examples in a minute. Do you guys have any questions here about overload operators? So if you did complex num a is equal to 5i plus 9, that wouldn't work because 5i looks to the compiler like the number 5 followed by the variable I. Right? So that would not work. Like what you could try doing is you could overload the equals operator to accept a string, right? So you could say like, and then have that parse the string to get the arguments. And then you could say like, my a is equal to the string 5i plus 9, and then that could work. But you couldn't just do 5i plus 9 because, again, it's the value 5 followed by variable I plus 9. And if I is not defined, that wouldn't work because I doesn't exist. And if it is defined, there needs to be some operator between the 5 and the I. Oh, okay, so you have two separate namespaces, and inside those namespaces, you have a class of the that name. Yeah. And so you want to have each one of them be castable to a like bool or something. So if you wanted to be able to do that casting, you'd have two operators. One could just say like operator A parentheses, right? The other one would say operator B : A parentheses, right? You specify the A in the other namespace. Any other questions? Yeah. Say it again. If the type you're trying to cache to is in a different namespace than the one that you're in, yes, you have to pass the, you have to do like the full type specification that includes the namespace. So namespace : type. Or if it was like even more nested, like namespace 1 : namespace 2 : type. There was two namespaces within it. Oops, hate when that happens. This one? Yeah. Okay. So we'll show this in action now, but we won't do a complex number because you guys are probably tired of that. And we'll do a fraction instead. Where did that go? There should be something that says operator overloading in here. Did I miss it? Oh, I guess I just forgot to put it over there. So, what operations would you want to define on your fraction? Well, so we might define the stream operator, right, so we can print things out. We might have a fraction constructor over here that has like the number 0 for its numerator. The denominator starts as 1, right, because fractions have a numerator and a denominator. We have our copy constructor, which is just going to be the default one, right? Make our num equal to the right-hand side's num, make our denominator equal to the right-hand side's denominator. Operator equals you can define. It's the same thing as being normal. We have some functions to simplify it, normalize it. You might want to flip the operator, but in terms of some of the functions, you might want to be able to negate your fraction. So operator minus, no arguments. And again, we turn a copy of ourselves and we're const, right? We shouldn't change because of the negation, right? Right? You have minus a. Should minus a change a? No. So you want negative a. You might have plus equals, right? We might want to be able to add a fraction and an integer. And then, oops, plus again, fraction and integer. And then we also defined a friend function again so they can access our private members. And so we can do an integer and a fraction. Again, we could do like a lot of the same things for a subtraction operator. Minus equals minus, times equals times. So again, we just define this one solely as a friend. Divide equals divide, and then you might do exponentiation using the caret. We also have a cast for ourselves over into a double, so we can get the fractional representation of our value. And then we have some other functions that are like handle sign, and we have another function that finds the greatest common denominator between two numbers. Because you might need that for like doing some of the normalization. So again, here's our constructor. Shouldn't seem too crazy. We get our numerator in and then our denominator in, and then we normalize ourselves, right? So if I get something like 10 over 5, I get it over to 5 halves instead. So the value gets simplified down. Or I think this, no, it doesn't. That doesn't do that. Simplify or normalize. Normalize. There it was. So it handles the sign and then simplifies, because if someone does like negative a over negative b, it should just be like a over b. Or if someone does like a over negative b, it's a lot easier to always guarantee that the negative sign ends up with, like, say, the numerators instead, so that the negative sign would be moved over to the numerator. So handle sign here. So if num is less than 0 and denominator is less than 0, or num is less than, or denominator is less than 0 and the numerator is greater than 0, we want to negate both of them. We want to make sure that only the numerator is negative. So if they're both negative, right, we need to negate both of them. But if only the denominator is negative, again, we still need to negate both the top halves. So here's operator plus equals, right? Remember, when you add two numbers together, two fractions together, right, you can't just add the numerators and add the denominators. You'd be surprised by how many times I've gotten that answer for a question before. First, right, you have to multiply your numerator by the other guy's denominator, and then multiply his your numerator by the other guy's denominator, right? Gosh, that's being said terribly, right? Come on. Right, if we have a over b plus b plus c over a, right, the resulting numerator is going to be not c over a. All right, it's going to be a times d plus c times b as our numerator, right? And then our denominator will just be the two denominators multiplied together. And then we normalize ourselves so that we're not going to be a more complicated number than we need to. Again, if we turn into like 5 over, or 10 over 5, we turn into 5 over 2. And then we return a reference to ourselves. And then again, this is what I was saying about like reusing our code. We create a copy of ourselves, copy plus equals the right-hand side, and then we return the copy. We don't have to keep rewriting the exact same thing that I had above. You guys have any questions here about any of these methods? No, we're all cool. Operator overloading makes sense. Yeah. So the type of this is a type pointer, right? It's a pointer to an instance of this class, right? But my function said it was going to return a fraction reference. So I have to dereference myself to actually become an instance of my class instead of being a pointer to my class. Any other questions? Okay, then very quickly, we will talk about friendship and then we'll leave off for today. So again, when you declare someone your friend, they get access to your private parts, so they're able to mess with anything and they have no more restrictions that you would normally provide. But you know, we do have data encapsulation and protection for a reason. It provides data hiding and encapsulation. People on the outside don't have to know how we work internally to get the job done, right? They just have to know how our nice public APIs, how to call our nice public APIs. They don't have to worry about the details of how those tasks are accomplished. That's going to provide a very nice and clean interface. It's also going to prevent people from monkeying with things they shouldn't be touching and breaking those things. And this also makes it easier for us to be able to update our internals as well. If people don't have access to those things, right? As long as we only change our insides, we can push updates and not break anything, right? But if we start changing our public APIs that people are allowed to access, then people might have to go rewrite their code. Because if we exchange the order of two variables and everyone was calling it was AB and now it's BA, now everybody else's code just broke. So you have to be careful with updating those public APIs. So you want to expose as little as possible to make your life easier. But there are some times where only one or a few very specific classes or functions need the ability to access some of our private or protected data members. It might not make sense overall to provide getters and setters for those things if other people are going to be able to use this class, if only we're supposed to be using them internally, right? So they need to be marked private so people on the outside can't monkey with them. But we still need to have some way of having the access, so we kind of need the friendship. Or another thing that you might try to do is implement the singleton pattern. In the singleton pattern, you only have like one instance of that class, right? And then everybody, the first time somebody asks for an instance of that class, you go make a new one, and they get a pointer to it. And in the future, anytime anybody asks for an instance of the class, they just get a pointer to that same object. There's only ever one instance of it. The way that you could make this happen is if you had like a function that's called like get instance of, and it returns an instance of that type. But that function would need to be able to call its constructor to actually be able to instantiate the object. But if the constructor is public, right, anybody can now go make an instance of that object, and you've broken the ability to make it singleton, only have one. So you'd have to go make that constructor private, so no one else could create instances of it, and then go make your function get instance be its friend, so that it could call the constructor to be able to build an instance of that object. So again, if somebody's your friend, they have full access to all of your stuff. Again, you can remember the joke that we made earlier that friends have access to all of your private parts. This is going to allow trusted classes to have full access to you and do whatever they want. So if you want to declare somebody as being your friend, inside your class definition, you write friend, name of the class you want to be your friend. Or if you have some function that you want to be your friend, friend, signature of that function. That function is now your friend, has full access. You can also declare only a particular method of that class to be your friend if you wanted to. Only that function, only that method has access to you as a friend. So A made B a friend. Now B has full access to A. Right? Here I made the function max that returns an integer that accepts an A of B, my friend. Here I made only C's foo method that accepts an A, my friend. So you can do things like that. We'll pick up on this next time. It's not too complicated with friendship. And then we'll also, again, go into some more complicated examples, hopefully on Wednesday. It's really important that you come to discussion this week because we will be covering new topics in there that you will need to know. When you only wanted a particular method, I can't come up with one off the top of my head. Like, I think like maybe like the idea is that, again, you want to limit the amount of access that you're giving somebody to be as little as possible that they need. So if the only time they need to access your internals is in that one function, you make that one function your friend.
Well, then what do you do with defining that one function? Because you might have secondary implementation.
So there's a difference. Like friendship is not transitive. If I make you my friend, I'm not necessarily your friend, right? So it's back here, right? B is A's friend, so B has access to all of A's internals. But A is not B's friend, so A cannot access anything inside B that's not public.
Quick question first. Just making sure we're defining constant references just to save memory.
It saves memory and it also saves time because we don't have to compute, we don't have to make a copy of the thing. Also, the other thing is that sometimes things aren't copyable. For example, the streams we just talked about today, they're not copyable. So you can't have a function that accepts an Fstream. Right? Because that would be making a copy of it. But you can have something that accepts an Fstream reference. Yeah.
And second, when we're overloading operators, when do we use them like this? Like this, and when do we use them?
It's up to you. I always use them like this. But there's two different ways of calling that function. You can call a function like this. It looks like, the function call is being hidden, right? Because you don't see dot anything. So there's like a lot more explicit way of calling functions.
So we
but
don't
both
have
do the
to
same
use
thing.
the keyword operator if you're defining it in the same class.
Right, this is after you've already defined it, and this is in your code where you're trying to call the function.
Yeah. So we can just call it like this and add like do the operation on F1 and F2 instead of doing F1.operate.
Correct.
Is that midterm this Friday?
For our midterm, does it matter how many structs we use or the source file, number of source files, or we can use as many as we want?
You can use as many as you need.
So I only have one struct, that's fine.
Yeah, I mean, I would kind of recommend breaking the problem up a little bit finer, but you won't be penalized for it, just for practice.
How about global variables?
You also shouldn't have any global variables. If you're passing around global variables, it probably means they should be encapsulated inside of another struct.
And how about, if I use global variables for my midterm, I won't be penalized, right?
No, we're not looking at it, but again, your design shouldn't be. Well, I mean, like, even within the source file, they shouldn't exist. Right. Global variables are useful.
Or like the file that you're trying to write onto. This is like, generally like if you might want to go like beyond like a board or something, like have a game, right? And the game has a long file inside of it, and I can pass the game around everybody. My phone now. So when you go to the increment, so you don't have the file, it's like if you press like if you go back, so if you just press like the back button or whatever, or press it back. Yeah. If you go to grade and move it to submission, so that problem, and then pointers. And here, this is just having an issue that somebody else has, where it's not like actually getting any of the files. So what you can try doing, I'm making an instance. So like assign it. This is just start out. Then go to like your zip folder. And now I try to make an edit because that was working for other people. So now when I go to the one, it's an editor. Most of your functions weren't finishing. And some of these only have this, which then means I don't know why they don't have the city here. Actually, that's like I'm not sure. This one did finish. This pressure 0 did finish. So you do have an answer, right? So if I my answer is, why does this one not have output? I unfortunately don't have time to look more now. Now what's up? But it's obviously compiling and running it, and there's something like this with programs where it's not finishing on some of them, and it looks like for all of these, it didn't produce any output. This makes sense. And if you go back to that, if you go back to the protocol today, and go back to the back again, so you can go back. And then you can go to the grid, and then you look at the vehicle history. And then if you scroll down, and if you look at like horizontal when player 1 got out, it's like this one, like this program didn't produce any content for the other reason. I don't know what the issue is, but that's totally comparing to it.